Okay, let's get started. First off, welcome to the Banking on Big Data webinar. My name is Stacy Gorkoff. I am the VP of Marketing and Channel Development here at INETCO. I just wanted to say a big thank you to all of you for making the effort to join us today. I promise to try my best to make this worth your time. A couple of housekeeping details before we get into the actual content of the presentation. If you have any questions, please just enter them into the participant chat box. We will try to get to as many of them as we can at the end of the session, and you can find that little box in the bottom left-hand corner of your screen. This session will be recorded, so we can send out a link in the next day or so. And we'll also be asking a couple of poll questions, so we would love for you to participate. It definitely gets lonely out in space. Now, I'm going to assume that the majority of us are working for organizations that are putting a very, very high priority right now on things such as digitizing operations and really bringing customers to the center of business activities. This assumption is somewhat backed up by some of the research reports that we've been reading. In particular, there was one that was published by DBR Research in December of 2018, and that indicated that over 50% of the global banks that they surveyed were ranking the customer journey and doing more with big data as the top 2 retail banking trends for 2019. Well, the good news is that a lot of the recent data points also suggest that the ATM channel will continue playing a key role in this ongoing transformation. We're seeing certain advancements around interactive teller support, more targeted banking options for customers, the enablement of cross-channel interactions, tap and go, and just the addition of alternative services on the ATM. With all of this, we think that there is a real opportunity to reinvent the ATM experience. Now, the tricky part is not getting trapped into advanced ATM technology for the sake of technology. I think it's super easy to have a little bit of a tendency to want to add a ton of services and customize everything in order to make it unique and different. But without the right knowledge, a lot can go wrong with your customer-facing self-service applications. And this is why it's so important to really understand how your customers are choosing to interact via the ATM channel. The challenge is that there is often a gap between what we think and what we know about customer engagement. So if we just take a moment to consider even convenience, are we fulfilling customer cash and payments needs? Are we doing this anytime, any place they want to see us? Relevance and responsiveness, are we offering the right services at the right time? Reliability, of course, are customer transactions completing as expected? These are all very, very important things to consider when we talk about customer engagement. But on the flip side, putting the finance hat on now, there is also some key data points to consider when it comes to optimizing your ATM operations. Now, sure, we have to satisfy customers, but we have to do this in a way that makes business sense. At the end of the day, we all think, and I think we all know this, channel profitability is going to be key. We know also that certain costs are rising, and these costs are often related to cash or the resources associated with, let's say, distribution, maintenance, and payment processing itself. Now, any data that can help us monitor and make decisions related to things such as cash forecasting, ATM utilization, customer service preferences, perhaps weighing outsourcing options, this is all gold to us. So when it comes to closing the gaps between what we think and what we actually know about things such as customer engagement and optimizing ATM operations, this is really where real-time customer transaction data can help. It's all about finding answers to questions that may be related to customer experience, that could be related to operational efficiency, or even fleet optimization, and finding these answers in a timely, cost-effective manner. Some of these questions may include who uses the ATM channel, when and where, how much cash is being utilized, and where are transaction anomalies, ATM cash outs, and other attacks actually occurring. And of course, there's other questions that come up in regards to how various hosts and networks and applications are responding, and also what type of services are being used, and actually how frequently are they being used. So anyone, and this is coming from past experience, anyone that has gone down this path of trying to harness real-time transaction data, you've probably faced a few challenges on your path. First and foremost was the data collection itself. So the challenge is that we're dealing with massive in-flight data volumes. We're faced with expensive, or we have been in the past, very expensive, hard-to-scale data storage. And then the ability, just the sheer ability of being able to gather data across multiple sources and systems, especially in highly distributed environments, getting to the point of consistent data gathering is a tough thing to establish. When it comes to management and normalization, of course this challenge is very simply garbage in equals garbage out. Data quality matters. And I think that a lot of us out there, we realize this, and we definitely, it's a work in progress when it comes to trying to overcome issues around data governance and perhaps clarifying the processes around who actually owns the data itself. On the visualization front, this is definitely, there has been a challenge in understanding and sorting through all these huge volumes of data to know which data actually can drive impact. So the problem here is also avoiding analysis paralysis, we like to call it. Without the ability to produce actionable insights, it is definitely tougher to build a compelling use case for real-time data. Data sharing is another area where traditionally it's been a little more challenging. Real-time execution is tough. Being able to get data to a ready-to-analyze state, this often would require a very long wait and a very heavy analytical effort. In the past, cumbersome technologies and often a lack of a data pipe structure was definitely something that was hindering the ability to share data, integrate data, and provide that on-demand accessibility we all need today. Now the last area, the predictive and machine learning algorithms, especially those that are specific to banking and payments, the challenge has always been how do we build the right capabilities and the right team for proactive and real-time usage. And how do we do this without each of us needing a PhD in mathematics to create analytics? Now, these were all problems that have definitely been faced as we go along this journey of trying to harness and to really utilize real-time data, but luckily technology is evolving. And I think some recent areas worth noting where we're seeing major advancement is actually in the collection, the decoding, and correlation of real-time data. So it is now possible to capture, to normalize, and to centrally store quality data. This is gathered in a consistent, trusted way across all channels and systems, and it's done so in a very cost-effective fashion, which is perfect. Real-time transaction monitoring and analytics solutions have also come a long way. We look at user interfaces that are now way easier to use. We look at Tableau, Microsoft BI, some of these interfaces that you do not need to have a PhD. They do not require heavy analytical effort to use them. There's a lot of built-in algorithms that are payments and banking specific. Essentially what we're doing is we're taking data down to a point where it's friendly and easy for anybody to use that needs it. Now, real-time data feeds and custom connectors is another area. In the world of open data that we live in today, I can't stress enough the importance of thinking about data sharing, the integration of data within other applications, and just this concept of on-demand accessibility. Luckily, a lot of today's data pipe structures, they open the options and they help us to expand the use cases for real-time data to virtually any application or team that would need it. Now, at this point, let's go a little bit deeper into the value of transaction data itself. So banks that have access to customer transaction data are really sitting on top of a gold mine. Each transaction contains both application level details, so this could be payload, metadata, response and request times, and network level details down to the TCP IP acknowledgement level. And both of these data sets are useful when they're contained together, and they can be valuable across a number of use cases that we'll delve into a little bit deeper today. So I like to think that seeing is believing, and this is just an example of what a transaction profile could look like. In this case, it's structured from more of an IT operations perspective. Now, what we're seeing here is that each end-to-end transaction is made up of a variety of transaction message types. We can see these listed down the left-hand side all the way down to the linked messages level. The idea is to think about a transaction correlated from end to end, from the moment that somebody puts a card into a machine or taps the machine to the point where it's authorized and on the way back again. Now, another part of the transaction itself is the information such as the application metadata and the payload messages. And this is where you'll find dollar amounts, terminal IDs, transaction types, status codes, response codes, etc. This is very, very valuable for alerting in real time to operational performance issues and transaction anomalies, but it's also extremely valuable when we start thinking about sharing this in analytical applications to understand things such as channel profitability, forecasting cash utilization, and knowing when, where, and how customers are choosing to engage across all their channels. Now, message timings is also a very important part of each transaction. This is where we can actually see how application response and request times are working and identify when bottlenecks or failures are occurring and isolate exactly where that's happening. So finally, adding on top of this the network level information, and this is the information down to the TCP acknowledgements, network communications intelligence. All of this information is also contained within the end-to-end transaction profile. So all of a sudden you can see the power of being able to provide this one-stop view into how all your various cache points, your hosts, your networks, and your applications are responding. So that's just an overview of what we mean when we're talking about transaction profiles and all the rich data contained within. Now, who benefits from all of this real-time data anyways? Well, for now, we're going to focus today on three main use cases and three main user groups. The ATM operations and channel systems teams. These are the folks that are interested in looking at things from perhaps an operational performance view, looking at ways to resolve issues and isolate issues faster. From a line of business and channel management perspective, taking the data into an analytical view where we can start looking at trends in customer usage, understanding what the customer is actually experiencing, and how they're actually interacting with the ATM channel or any of your other channels of choice. From a fraud perspective, this is really another added layer of defense. We call it early warning fraud detection, whereby you can come in, you can actually start looking at the data. Again, that end-to-end view becomes invaluable when you start thinking about perhaps malware sitting on a switch that's not enabling a transaction to actually complete as expected. So let's say there is a front-end ISO transaction, but there's no back-end database transaction. Things like that can be picked up so that you can quickly identify where there could be potential ATM cash outs happening and that sort of kind of logical attack. So common real-time data use cases for each of these groups. For channel operations, it's real-time, end-to-end transaction performance monitoring. And this is looking at real-time alerts that may be related to transaction failures, service response slowdowns, stand-in modes, also identifying if there's networks or third-party applications out there that are down or not responding the way that we would expect them to. For channel managers and line of business, it's more about looking at being able to actually have on-demand analysis or an ongoing view into how customers are interacting and how the channel is performing. For fraud, again, this case of fake processing, So if there's malware sitting on a switch that's not enabling a transaction to complete how we would typically expect it to complete, picking up on things like that related to ATM cash outs, also implausible transaction scenarios. So knowing about various increases in amounts, if we see a high velocity of transactions occurring, or perhaps repeat card or terminal activity. These are all signs and symptoms of potentially an attack occurring. So at this point, we're going to ask our first poll question here. And really what I want to do, we're going to delve into these 3 use cases in a lot more detail, but I would love to know from you right now which of these is of most interest to you, so that we can cater the rest of this presentation to your interests. And I'm just going to skip to the results here. Great, okay. So we can see that this is interesting. So fraud detection is definitely of interest here. Oh, we have a little bit of an even split. Let's just see. We'll give this another, let's say, 30 seconds, and then we can close it out. Great. Okay, so it's quite even, which is perfect to know. We can definitely concentrate a little bit more on the customer and channel analysis, and the fraud detection. We'll go into a little more detail there. But let's close out this poll here. And I'm just going to go back to sharing my slides. There we go. And we will start with the first use case. So end-to-end transaction performance monitoring. Now, each of these use cases, I'm going to bring one of our customers into light here so that we can talk about what's going on and what their challenges were. With FIS, when they first engaged with INETCO, the biggest challenge was all the mergers and acquisitions that they've been undertaking. There's blind spots on the end-to-end transaction path, and of course, it was getting a lot tougher to quickly isolate issues spanning multiple applications, multiple networks, and multiple hosts. As part of the results of being able to get in and use real-time transaction data, what we were looking at were operational efficiency gains, where we were able to reduce the average mean time to repair by about 65% for them. We also looked at ways to reduce time and support costs, and these were mostly associated with centralized data gathering and reducing the number of things that were happening in silos, so troubleshooting of the applications team, the network team, etc., by actually consolidating all of their tools and offering a one-stop view into application performance, network delays, and transaction level messages. We were able to actually provide a method of savings when it came to the actual operational costs themselves. And then improving customer service levels was a big part of this story as well. So all of a sudden with access to real-time transaction performance data, they were able to look at things such as the proactive identification of network latencies, authorization denials, out-of-service point of sale and ATMs, and also hone into suspicious transaction activity. Now, these next few screenshots are just to show you, give you some examples of what transaction data could look like within certain platforms and applications. So with real-time transaction data, you can see the correlation of transactions across various hops and protocol types. And this is not just across one channel, it's across all of your channels. We can see on this left-hand side here, it's more set up for e-commerce. The one in the middle is an ATM network, and the one on the right is a lending host application. So the idea here is to visualize all end-to-end transaction flows, see how many transactions are actually occurring on each hop along the end-to-end transaction path, and identify if there's any slowdowns or failures that are occurring. Now, we had talked a little bit about the rich transaction messages that are available within each transaction itself. And this is where that is invaluable when it comes to customized alerts. So these can be set up on a number of fields such as application response times, card activity, host availability, transaction velocity, declines, fallbacks, and all sorts of things such as like a lack of message type, etc. So these are alerts that can be set up for slowdowns, failures, anomalies, very, very customizable when you have access to all the message fields. Now, another area where we could definitely add some value when it comes to seeing every single transaction is being able to quickly research and find your way through a transaction log. You can do a search and a filter based on, it could be status, it could be the actual type of transaction, hashed PAN numbers, terminal IDs. The world is kind of your oyster when it comes to needing to quickly identify a transaction that's caused some sort of grievous moment. So we've already talked about transaction profiling, but just here's an example here where we can actually come in and we can start looking at various information in one single pane of glass. We can see that NDC messages and printer data may indicate that various sources of the actual decline, so it could be that an issuer is unavailable. Now the transaction also shows all the network level information, so that's your TCP acknowledgement information. And there we can see that it indicates that there actually was no network problem. The financial transaction request went out to the host, but it never made it back from the host. So the problem most likely would reside with the issuer host itself. So that's a little bit about the FIS use case. These use cases are available online, and I think we're going to be sending them out after this presentation as well. So moving on to use case number 2, this is all about looking at things from the channel management or the line of business perspective. Now, one of our key customers that we've been working with for the past little while is a company called BECU, or credit union that's based in Washington. Now, their biggest challenge was looking at ways to improve member engagement, and this became really tough to do because they didn't have a proper view into transactional data. So with the ability to take data and provide central visibility into every member interaction, what they were able to do was take this data and apply it to a number of various applications within their business. They set up instant notification of transactions not completing as the customer would expect, more of an operational view. They set up fraud-based rules meant to identify ATM cash outs, more of a fraud-based view. They took this trusted data feed and they actually forwarded it onto their cash management system of choice. So that was more from the cash management, understanding cash utilization view. And then they took data and they actually are using the Tableau interface to take this data and to start looking at things in terms of ATM placement, understanding the transaction and service mix at the ATM, as well as looking at cash utilization analysis. So there's multiple use cases, same data set. And these are just some of the examples of the dashboards that they've built out today. This first one is an executive view, where essentially we're looking at how ATMs are the ATM channel is performing from a business perspective. So how does this week compare to the previous week? Looking at profitability, transaction volumes, who are my top performers, where are they located, also at ATM failures, so what has been affecting profitability to date. This next one was more around channel performance. So how is the actual ATM fleet being used by my customers? Here we can see the volumes, the revenues, the channel profitability. This could be done for an individual ATM or could be a group of ATMs. Now, this can also be done on a customer-by-customer basis, and we will show a screenshot for that in the next little bit here. But when you start thinking about the value of this, it's really starting to understand, okay, so what is the transaction revenue composition on each of my ATMs? It's understanding the number of transactions that may be exceeding specific or specified dollar amounts. It's understanding the breakdown of transactions itself and the mix of withdrawals, deposits, et cetera, that are occurring across your fleet. This example is to do with the actual forecasting of cash itself. Now, because we can see all the cash in and cash out information for each individual ATM, all of a sudden it makes it really, really easy to use granular transaction information such as transaction types or cash denomination values, taking all of that information and starting to either look at it within an analytical perspective or driving the need for that data and feeding it into your cash management system of choice. cash forecasting can be done on the fly. So this is essentially you're going to review all your volume trends at various cash points. What we're showing, the green line, is the actual cash levels that have been fluctuating within the ATM itself, and the blue line is more or less how we've looked at forecasting that cash. So you can start to tighten up the algorithms. You can start actually overlaying and seeing how accurate you've been with your own forecasting. ATM placement was a big use case for BECU. What was interesting was they were able to reduce the time it took and the effort it took by about 65% with the use of real-time transaction data. So in this case here, we're going to hone in on a terminal 0187, and we're going to take a look at this and essentially notice that the transaction volume has definitely increased over the past 10 months. We can also see this is an algorithm, banking algorithm that is built in that enables us to look at queues. We can see that there's been over 2,000 episodes in the last 10 months where we have a queue length of about 5 or higher. And then we've got a look at actual competitive data that's been brought in from a data source. You can actually start seeing that the competitor ATM was placed right next to this terminal. What are the chances that we're going to start seeing less customer interactions due to this and to the queuing issues? And then we also see that customer acquisition and engagement, by actually taking some of the demographic information we know about our customers, we can see that the density is increasing in the area where 0187 is located. So these are all valuable points, and being able to showcase this and put together all of this data in one screenshot is definitely of value. Now, I had mentioned earlier that you can also take a look not only at how each ATM is performing, but starting to look at perhaps how a customer chooses to interact across all your channels. So in the case here, we're honing in on one customer. We can see what type of transactions they're doing, where those transactions are occurring, what channels and payment terms they want to use, what type of cards they're using. All of that information can be put together into one view so that you can start building out kind of more of a responsive path for each customer. Card usage is another way to take a look at this transaction data. So perhaps you want to know which cards are your customers using and when. The evaluation of specific card programs, ensuring that one is not cannibalizing the other. You can start breaking down by card type usage, transaction amounts, and the actual dollar amounts themselves, and of course the transaction types. So this is just another way that you can perhaps start gaining more insight into your data itself. Now, again, the BECU use case is on our website. We will send that out, and if you have any questions about that, just let me know. So the third use case that we're going to talk about today is all about early warning fraud detection. And this is, in this case, ATM cash-out attacks. Now, we had a customer come to us, and they actually had experienced an ATM cash-out attack. This was a fairly large bank in South Africa, and essentially what happened, they had over 100 plus people that started using forged credit cards to withdraw over $19 million from 1,400 ATMs in one city in under 3 hours. What happened was these transactions were being approved within the bank's environment, but there was no visibility into those transactions. So they came to us and they said, can you provide details about the real-time transaction data, the correlation, the end-to-end view into a transaction that could help us identify when these types of attacks are occurring. And what the result was that we provided some ideas around some real-time alerts that you could do that would add another layer of early warning defense against ATM cash-outs and switch malware. And I'm actually just going to jump into some visuals here that will help us explain how we helped out. So in a typical man-in-the-middle attack example here, we see this lovely gray blob is my malware attack, and it's sitting on the transaction switch. There are 3 points where the transaction is inflowing and should be flowing. Number 1 is where we're seeing transactions coming in from foreign terminals. Number 2, they could be coming off of your terminals. But the idea is that each transaction hits the authorization host on the back end. That is usually where the risk monitoring sits, and then they come back again. But in this case, the malware was actually saying, no, the transaction's approved, nothing ever hit the authorization host. Well, there's a few scenarios that could happen in a case such as this. It could be that counterfeit or compromised cards are used at a local or foreign device. It could be that malware is forcing that authorization locally. It's overriding fraud rules that are sitting maybe even on the back end. And then the fact that the authorization and fraud systems never see the transaction, if you don't have that end-to-end view of transaction data, these are all things that could potentially be missed. So visibility into real-time transaction data. Because you've got that end-to-end view, as we mentioned before, and it's correlated across all of these various hops and links, you can all of a sudden know and be immediately alerted to things such as high volume or unusual repeat card usage. This could be from on-us or off-us locations. We can see repeat terminal usage from foreign cards that is maybe set outside set thresholds. And then missing back-end transactions, so things such as mistake processing, unexpected stand-in modes, or EMV fallbacks, for instance. These are all the things that you can start picking up on. And again, we call this another layer of defense because I really don't believe that there's any silver bullet when it comes to fraud, but it definitely helps to have a multi-layer defense strategy if you seriously want to start thinking about early warning fraud detection. Just to summarize how real-time transaction level data can help, this idea of multi-point monitoring versus single-point monitoring is key. So being able to independently audit and actually see the end-to-end journey of every transaction in real time from various points on your network enables you to pick up should a transaction not be completing or going across a link that it should be, if malware is actually rerouting, etc. Visibility into all transaction message fields. So with that visibility, you can quickly identify if any message field is being manipulated or anything is being tampered with. The real-time alerts, so we look at this as almost a backup system to your fraud system alerts. There is definitely no harm in having another set of alerts that can let you know should certain systems be overridden by malware. You can flag transactions, you can trigger action. Multi-hop, multi-protocol correlation is kind of the secondary step to the multi-point monitoring. So being able to correlate, understanding within, and it could be multi-protocol, but actually finding those fields that enable you to correlate and see an end-to-end transaction is key. And open data access. So we do have customers such as eGlobal that have opted to take all of these rich transaction message fields and port them over to their fraud management application of choice. The idea is that you may have proprietary algorithms. It just makes more sense to use that as your visual point, but that's definitely something that can be considered and done with transaction data as well. Examples of customized real-time alerts here, the missing back-end transactions that help us identify man-in-the-middle or malware attacks is key. If we're seeing a rise in transaction declines or unexpected EMV fallbacks would be another, or high withdrawal velocities or abnormal numbers of those high-value transactions happening. That's all things that you can be alerted to in real time. So this is another quote from eGlobal. And again, this use case is available off of our website, so we can share that one with you as well. Just to summarize the benefits here that we've talked about, and then we're going to open this up for questions. For IT and channel operations, it's really looking at ways to optimize the ATM fleet, lower the support costs, consolidating tools, and looking at ways that you can speed up the troubleshooting, the research, the isolation of issues. The side benefit of all of this is that you can actually also improve your availability, and we have customers that are reporting, on average, reduction in transaction failures by about 26%. For line of business and channel managers, this is getting to the data you need to make timely decisions. It's analyzing customer data to improve the service engagement. It's about looking at channel profitability, making smarter decisions, and increasing responsiveness overall. For fraud and security, it's this extra layer of early warning defense. So adding an independent multi-point monitoring system, looking at things that can help you combat ATM cash outs and various malware or logical attacks. Now, by all means, the use cases don't stop there, and the more and more we talk about real-time transaction data platforms, the more use cases have seemed to emerge. It could be around transaction reconciliation. We're definitely seeing a lot more questions about various third-party applications out there. So if any of you have questions about your environment, or perhaps there's an issue that you feel very strongly that better access to real-time transaction data can help with, perhaps it's an efficiency, an optimization, or just better customer engagement, let us know, because we're more than willing to have that conversation with you. And with that, we can move into our next poll question, our last poll question, and it's more or less just to let us know if there's anybody at this point that would like to have a follow-up discussion. When would you like us to reach out, and what is the best way for us to do that? So let's see here. Okay, we have results slowly trickling in. And if I look at these, I mean, we can share them with you, but it's good to see. There's folks out there that definitely are looking at, things immediately. Love that. 2 weeks, 1 month. It definitely gives us an idea of when is best time to maybe re-engage. And as I said, we will share these use cases. The plan is to actually take this and write a white paper that's focused on this information as well. So at that point, we can share that with you. And should you have any questions, by all means, just reach out to me. I'm just going to close the poll here, and we'll go back to these slides. Great. And now into the fun part, which is the questions themselves. So excited about this part. The first question, of all bank customers, I'd assume there is a subset that needs physical cash for their transactions. How big is this subset relative to all bank customers? Aren't many of us moving to mobile banking for many kinds of transactions that do not involve physical cash? So the answer is yes. There's a lot of folks that are moving to these types of transactions that do not involve physical cash. But it's so funny because I was actually just reading a report that was issued by Solent. It was research that was done by Solent and Samsung that was still claiming that, and it was a U.S.-centric report. There were 2,500 customers that were surveyed. There was still a claim that 80% of those customers were utilizing the ATM channel. So whether or not this movement is actually going to become a one-stream channel, I don't see that. I see us building out an ecosystem where the ATM still plays a very, very important role. Thank you for your question, for sure. Can you collect omni-channel transaction data? The answer is yes. So again, we believe, and something that we've been striving for, is consistent data collection across all channels. The idea here is that the more data, the more consistently we can collect it, the easier it's going to be to use, and the more valuable it'll be. Especially in relation to the last question that was asked, we are building out an ecosystem. There is no one channel that the customer engages with. And it's funny, I'm full of statistics today. The other report that I was reading was one that had come out from McKinsey that was essentially stating, even though it was something like 80% of transactions were happening over the online network and the online channels, only about 25% of actual sales and interactions were happening over those channels. So it still indicates that people are going elsewhere. It has to be an ecosystem that can serve up a number of folks in different ways. Are you able to share how the queue lengths are being determined as per the earlier slides? Was there a clever algorithm formula, or was this through observation or another method? No, it's algorithm. So what we were able to do was actually pinpoint the point where a card enters and the point where a card exits. We can tell all of the transactions that are a subset. So if somebody is doing withdrawals, deposits, etc., as part of that transaction or their interaction with the machine, we can pick that up as a subset. And from that point, we were able to actually start looking at the queues based on timings, based on how long it took for each card to be entered, and build out a queue that worked. So there is an algorithm behind that. It's a good question. Do you blend other sources of data with transaction data? The answer is yes. Now, as mentioned in this actual presentation, there are various applications out there, user interfaces. INETCO Analytics is a little more dependent on Tableau, but we've also built out dashboards for Microsoft BI, for Jaspersoft, for a number of different user interfaces. And each of these has the ability to bring other data in. So it could be KYC, know your customer data. It could be things such as demographic information. It could be maps. It could be sets of data that's competitive related, so understanding where all the ATMs are in your area. This is all information, when combined properly with the transaction data itself, becomes very, very valuable. What if we are using a combination of protocols in one transaction? Can you correlate them as well? So the answer is yes, and I think I touched on this very, very briefly. Let's go back to that though. Because we decode every message within a transaction, you have the ability to start looking for those fields that actually indicate a match, we'll say. So you've got the ability to take a front-end transaction, a back-end transaction. You can do this over multiple protocols and multiple hops, but it's truly, and back to that transaction profiling, we look at an end-to-end transaction as that full actual interaction that a customer has with you. Are we PCI compliant? Yes. INETCO Insight has been designed to meet PCI DSS requirements. There's a number of things that happen, such as track 1, track 2, the PANs, the CVVs, the encrypted PIN blocks. They're all either discarded, truncated, or subjected to a one-way hash. So in this case, we're aware of some of the data challenges, and we want to make sure that we are both PCI and GDPR compliant. Do we do risk scoring? So I love that question, because the answer is, we are actually currently working on implementing this within the INETCO Insight product. So a risk score, you will be able to calculate that for each ATM and each PAN. Now that score can be used to trigger alerts. It could be used to trigger HTTP requests. It could be queried via REST API and then viewed within the Insight console, or perhaps your own report viewing session. So the idea here is that we want to make that easy, and we are actually moving towards this ability to proactively stop transactions that appear fraudulent. So as we trigger an HTTP request, you can all of a sudden build this out so that the transactions are stopped, and we can decline when certain patterns or trends are detected. So I love that question. That's good. Are there any performance issues, latencies, or lags in the transaction with the solution? The answer is no. Transactions are captured off the wire. So this means that there is nothing that needs to sit. We use mirrored packets that we get down from a span or a tap port. And the idea here is that we can take that information, all the in-flight information off the wire, and analyze that in real time. So there is no intrusive agents that are put on the switch. There's no intrusive agents that are put on devices. It's a fairly clean, fairly easy to implement solution. Okay. So I think that's bringing us to our top of our 45 minutes. There are a couple of more questions coming in. I will 100% reach out and make sure that we answer those questions. If you have any other feedback, if there's any other way that we can help you out, please just email me. We can delve deeper into any of these use cases or your own use cases. We love having conversations. And again, I hope this was worth your time today. Thank you very, very much for giving us 45 minutes. Take care, and we'll talk to you again soon.